Hello everyone, welcome back to class number 2 again, part 2. Um, as we are finishing part 1, we just did not quite get to the physics domain and time domain. So let's express this one more time here. So if a physics domain, let's say is V is 120, 45 degree. If I wanted to go the time domain from here, Vt, so I have to multiply this by square root of 2, right? Then your cosine omega t plus 45 degree, right? So if I have something over here, let's say V is 200 negative 15 degree. If I go back to time domain for that one, it would be 200 square root of 2 cosine omega t negative 15 degree. On the other side, if I have something like, say, I have a time domain signal here is 280 cosine omega t plus 30 degree. If I want to come to the phasor domain over here, that would be 280 over square root of 2, and angle is positive 30 degrees. So this is the simple thing for time domain and phasor domain. So if I draw a signal over here, for example, if I draw a signal over here, let's say I'm going to draw this signal in zero reference over here. So that's this is a signal in time domain with the reference angle 0. If we come to this side over here, that would be right here, 0 degree, right? So let me make this same color over here. All right. So now if I draw another one, let's say take a red color over here. If I draw another one that is, let's say, is 45 degree ahead of this one. So if I draw something like this, so let's say that this angle over here is 45 degree. All right, so that means this is 45 degree ahead of this one, so that would be right here. So V 45 degree. So this is your 45 degree. So that's how you go back and forth from time domain to phasor domain. Again, we're going to solve this problem in the class. So let's talk about real power and reactive power. Real power is also called active power. Real power is also called active power, right? So real power is the power you basically consumed in the load. What is the reactive power? Reactive power is happens because of imbalance in the system. What I meant by imbalance over here, let's see how there are a lot of bikers here. All the bikers are not the same person, right? They have their different abilities. Some of them can pedal very quickly, some of them cannot pedal that much. If they're kids, they're going to take rest. So all kinds of things over here, right? So if that happens, to keep the thing straight on the line, the whole bike, you need to always balance. If it's trying to tilt another way, you have to balance it the other way around. So reactive power is like that. You want your voltage profile to be straight. It's the voltage profile, right? But it can try to tilt this way, or I can try to tilt this way. So that you have to balance it all the time. So this tilting happens due to the reactive power in the line. Like it happens because of capacitor and inductor. Mainly in the line, you have inductors because of flux linkage, and you have capacitance because of electric field. There's a voltage difference between line. So those things try to take your voltage one over other, and other needs to balance. That's how your reactive power comes into the play. So what I explained right here, again, is same thing right here. So that's what I'm talking about. So to keep it in straight line, you have to balance. So this is the power, straight line power entire supply. This is the real power right here. But this is reactive power. All right. Try to go one or other, so we have to compensate it with other kind of reactive power. So at the end, we do not want any average value of that. So complex power. When you come to the power, because of the angle difference and the reactive power in the line, it becomes a complex power. So what is complex power? Complex power is basically your VI conjugate. What is the conjugate here? Let me tell you this. If I is, let's take a very different number here. Let's take a, let's take a complex number here. Let's say your x is tan negative j10. So what is the conjugate of that? Conjugate of the tan plus j10. So if I do it in math over here, it would be in polar form 1.4 negative 45 degree, right? If I do conjugate of that, that would be what? 14.14. Your magnitude doesn't change, but your angle become positive. That's the conjugate. So this is the VI conjugate. So that your complex power is voltage times I current conjugate. So for this particular load over here, this is the voltage, this is the current, right? So this is the voltage angle from the reference here, theta V, and your current angle is theta I. So your VI conjugate will be V theta V, right? And I negative theta I because of conjugate, right? So if I now try to find the value here, magnitude to magnitude, and your angle over here would be theta V minus theta I, which we call theta. So VI theta. That's your complex power, right? So what is this again? This is, if you remember from your complex algebra, this is cosine theta plus j VI sine theta. That's your complex number, right? So this is your real power here. This is your reactive power. So real power, this is your P, this is your Q, right? Then your apparent power, magnitude of apparent power would be P squared Q squared. All right. So a complex power has both part, real part and reactive part. So real part is VI cosine theta and reactive part is VI sine theta. And your apparent power is magnitude of them. Same thing over here. This is another complex load. I hope you can do that on your own. So over here, your V is V theta V. Your I is I theta I, right? So you do complex power VI conjugate and do this and see what happens. You will see that what will happen to that complex power, and you can decide what kind of load is this. Look at who is leading. If current leading is capacitive load, is voltage leading. If current lagging, that's an inductive load. And for a apparent power or complex power for the whole circuit, we basically add each of them together. So this will be what VI1 conjugate, VI2 conjugate, VI3 conjugate, or I can do VI conjugate, the same thing. All right. So we're going to do this problem in the class, and I think that's all for the part 2. I'll see you in the class and solve the problem. So I'm going to use the class time to mainly solve the problem.